Hey guys, Matt here, and in today's video we're going to be looking at using the 3D Hubs file viewer to analyze how 3D printable some STL files actually are. Now if you haven't heard of 3D Hubs, it's an online platform that allows designers to upload STL files and then people with 3D printers to print them. So the website basically facilitates the whole payment and ordering system. Now one part of this is the STL file analyzer tool that's actually available to the public on the website. So anyone can go on there and upload a file and get all the analysis information that would usually be available to customers and people with 3D printers that are actually going to be printing the parts. So we're going to head over to the 3D Hubs website now and actually have a look at it. So here we are on the 3D Hubs website. The appearance of it changes from time to time, but the general process will stay the same. So the first step is to click Start Manufacturing and select 3D Printing. And this will take us to the order page where we're basically uploading a part. If you follow it through, it'll be sent to someone to 3D print it for you. But we're just going to be staying at this step one where you upload the part and view it. So I'm going to start with the 3D Benchy, just the benchmark test for FDM 3D printers. There it is, and it takes a little while to upload and process and everything, so I'll leave that for a second. Alright, so here it is, it's all done. I'm just going to put this in full screen so we can see it a little better. And here we go, so it's just a general file viewer to begin with. We've got a cross-sectional slider here, so you can slide that up and down and see inside the part, which is pretty useful. For example, you can see here this hollowed out cylinder, just there. I'll slide that back up. Then you have the different viewing modes up in the top left corner here. So there's solid, X-ray, which is pretty cool. It allows you to see through walls. So one thing that I didn't know about this part is it actually has text in here, creativetools.com, and the licensing information. Would not have seen that if I wasn't looking at this in the X-ray tool, I don't think. So that's pretty useful. Then there's the wireframe, pretty standard, just shows all of the triangles in the STL file. I'll go back to solid. Then of course, the banana. Click that and it drops in a banana for scale. If nothing else, surely you'll try it just for the banana comparison. So I'll hide that back away. There's also this measuring tool, which is pretty handy. You click that, so it changes from the cursor to the measuring tool. And if you hover over any part of your model, it'll show you the thickness of that in millimeters. So you can see that's 2 millimeters thick. The walls are about 2 millimeters thick. On the lip, 2.3 millimeters thick. Let's see if it's the same back here. Yep, 2.3 again. But also it has a part of it where you can click on one point in the model and then click on another point and it'll tell you the distance, which might be useful for some applications. So I'll hide that. Then moving on, there's these analysis tools on the side, which is where it gets really interesting. So we'll start with just the file details, that's name and dimensions, pretty boring. Then there's the mesh integrity feedback, which shows errors in the STL file that might cause problems when you go to print it or slice it. So it's detected some problems with intersecting faces and non-manifold edges, and it will actually show where those are in the model if we switch these sliders on. So let's see where the intersecting faces are. It's switched to X-ray mode and it's highlighted them in red. Now generally the 3D Benchy prints fine, so these aren't really things that we should worry about, but if there's big problems, it wouldn't help to run it through a mesh repair tool like Mesh Mixer or the Microsoft Cloud repair tool, which Prusa did a pretty good video on that recently, all the repair tools. I'll put a link to that in the top right corner. Anyway, then moving on, there's the non-manifold edges. Let's turn that slider. And it's detected some problems with that too, but again, nothing to really be concerned about with this model, but may be useful for other models. So I'll hide that. Then this is the most interesting part, printability by process. Now here it's got 3 different tabs, one for FDM, one for SLA, and one for SLS. Now, the first thing it does is run it through analysis to check if the walls are thicker than 1mm, because generally walls thinner than 1mm will be pretty fragile with FDM printing. So this model has passed that test, but then it also can detect intricate details. So little parts like this, the 3D benchy on the side, which generally isn't legible unless you've printed it really well. So let's show these intricate details and see if it highlights that. Alright, there we go. So it's highlighted in yellow, this part, because generally you wouldn't be able to read that properly. So it's just talking about where these details won't come out as sharp as they're modeled in. So these portholes here, the edges wouldn't be that sharp on an actual FDM print, which it's just pointing out. That's just due to the way the technology works, laying down lines of molten filament. So that can be pretty useful, especially if you want to tell clients that feature won't show through on the finished print or things like that. Then this is my favorite one, the hard to remove support issues. So let's show that, and it'll take a little while to process. Here we go, it's all done now, and it's showing you basically the areas where you might want to put in support material in your model, but it'll be hard to remove once the print's finished, either because it's in an enclosed space or there's not much room to stick in tweezers or pliers or whatever you want to use to remove your supports. Unfortunately, it doesn't detect bridging, so obviously we wouldn't use supports on the benchy because this is just a plain bridge, and this steering wheel only sticks out a little bit. But it's pretty useful for some other models. If you don't know there's cavities in there, or you just haven't spotted some spots where it will be hard to remove the support material, that's really useful to see. So that's all run through fine with the 3D benchy, but we generally know that prints and slices fine with FDM. What about an STL file that we know is corrupted and we know is going to cause problems in the slicing software? One of those that I can think of is the filament file on Thingiverse, which I see all the time posts on Facebook groups and forums of people having issues with that in the slicing software. So let's see what happens when we run it through the 3D Hubs file viewer, see if it picks up those issues with the STL. So I just downloaded this part and I've let the 3D Hubs file viewer analyze it, and let's run through it and see what issues it detects. We'll start with the mesh integrity feedback, and wow, just right off the bat, there's thousands of problems, literally, with this mesh. Let's see the intersecting faces. Might take a little while for it to process and find all of these. Oh, that was pretty quick. There we go. So it's found some problems through here and in different parts of the model, and the non-manifold edges. Let's see what it finds for that. There we go, there's some more problems here. Now, this isn't too bad compared to the benchy, but we know for a fact that this presents problems for some slicing softwares, so it's generally good to run your files through a repair tool, especially if it shows problems like these. Let's have a look at the printability by process. It's definitely detected intricate details, which we can see here, of course, but I want to see where the hard to remove supports are, so let's run that. Oh wow, that's really interesting. There's actually a cavity inside there, and it's saying we might need some supports here and here, these two parts. And what about in here? That's pretty interesting. Let's have a look at the solid view. Ah, yeah, I can see it now. Inside there. So it helps with things that you might not have spotted to begin with. In there might not print very cleanly without supports. And in here as well, in this cage area. Let's have a look. I mean, I know it's a small feature and you wouldn't see inside, but ideally that would have supports and you wouldn't be able to remove it. So that's pretty cool that it's pointed that out. So there's the analysis complete for the filament molten. I think I said that right. That's going to do it for today's video, guys. I hope you enjoyed it, and I hope you find that tool useful. If you'd like to see more videos like this in the future, be sure to subscribe, and I'll see you in the next one. Thanks for watching.